That's weird. Which assignment says 100 points?
Problem 7.1 through 7.8.
See, this one says 32 points. Why is it different for you?
No, see, I told you it's crappy software. You always act like I'm just crazy. Sometimes I may have made a mistake, but not always.
One's an assignment in the grades, and one is they're two different.
They're two different places. Oh, good. That makes it fun for me. So it's showing you guys two different things.
There are two different assignments of different values.
Of the same assignment?
The same
assignment? Okay. I can handle that. Delete the bad one. See if I can get everybody. That's better because I was like, well, I really thought I deleted and re-added them, but apparently I didn't delete them everywhere. You getting everybody? Chris, are you in your car? Don't drive. My lectures are way too entertaining to be driving. Dang, somebody could have a wreck. Look at all those people we have remotely.
Oh, actually, you did kind of well on this. That's good to know part of it.
Yesterday, this one kid in my 120 class, I mean, he is just barely out of high school kind of kid, left his mic and camera on, and so I muted him, you know, because he was talking and I could hear him saying really obnoxious things. So I muted him. And like 5 minutes later, he's all of a sudden on the chat going, oh my God, what did I say? What did I do? And nobody would respond. What did you say? You should be more careful. I finally said, yeah, I had muted you. It's okay, Chris. I was just worried I couldn't tell if you were driving. All right. Let's see. I've got Jacob here. And Chris there. Garrett. Okay, wait. Okay, I don't see Don. I'm counting Don absent. I don't see Jacob Angel. I've got Tori, Greg. Where's Garrett? Garrett B. Garrett Williams. I think it's here. Jackie made it. Stephen. Okay, I think I've got attendance. I've got Don, Jacob Angel, and Garrett Williams. counted as absent. Okay. Let's see if I can get this Kahoot. I got one question that I didn't finish. I'm going to set this thing to automatically go, so everybody will have to jump in. Wake up. Okay, go to www.kahoot.it and here's your game pan. It's just so loud. All those germs outside. Come on now. Every time someone jumps in, it restarts the timer when I do the automatic mode, so it'll kind of take it a second to get going. Good 12, that's pretty good. Some of our remote people have jumped in. Do the hard one right away.
It's a lot of reading.
I know, it's a mean Kahoot reading. Oh, very good. Remember, whenever you're looking at those one-to-many relationships, the many should point to the one with the foreign key. All right, what's select statement?
Oh, geez.
So you might have to look real quick. I don't see any of them that are right. They're all wrong. Well, they're all wrong. It says select user's first and last name, and then it only selects the first name.
Oh.
That's what I get for grabbing a Kahoot.
That's what I was thinking.
That's why you couldn't figure it out. Okay, so how would I find the password for the user with username SQL student? Good. Why was the blue one was wrong? Because it has two equal signs. So we use two equal signs in programming languages and not SQL. So good job pointing that out. List all usernames from the users tables. No users table, no other columns. Very good. Woohoo. Could almost had time to read that one. We use Management Studio to connect to which one of them? Good job. I didn't think anybody would remember that one. That was really good. List all users whose balance is over 10,000. That one's pretty mean, isn't it? Because they got the comma and the single quotes and those others that look basically right. Chris is on this. List all users' last names sorted alphabetically. Guess. Take your best guess. Very good guessing.
I was between the bottom two. Guess I'll tie.
Very good, very good. List the total of all users' balance.
Are you wanting the sum?
Maybe. That seems like a good guess. Very, very good guess. Chris just blazing through here, though.
Nothing happened.
Mary's on a streak. Which database management system can be easily used on the desktop? Yeah, it's kind of considered a desktop database. And we can use some others on the desktop, but not easily. It's a lot of installation going on. MindTap code activities use which DBMS?
Can't do anything with that? Oh, okay.
Very good. Chris just started out in the lead and just kept it. He's on this. Difficult questions. You guys are really good. Those are the only two that it popped up with. So yay. Thanks, Cahoots. I need to do some reading about this and find out what's going on. Is it gonna let you guys have a playoff or something? I don't know. I'm gonna close it. I don't care. Stop, Cahoots. All right, we were looking at our MindTap stuff. So many things, so many places, so many things I want to show you. Whenever you look at the code assignments, first of all, there's some confusion because those assignments have gotten doubled up again on the grade book. I'll get that fixed. But these assignments that we're looking at for our coding activities, the point values are in Cengage in MindTap. So if you see them on Canvas showing 100 points each or 200 points each or something, that's incorrect. They're not going to slam all that other work that you've done already like that. So there'll be a smaller amount of points. So that's good. Don't worry about that. Now, we need to clarify, though, looking at some of the different types of select statements parameters that we can use to get our select statements the way we want them. So I'm going to open back up the reading, and I'm sitting here at the picture of the database model that the chapter examples are using. And we're going to use that and kind of look at some of these examples, and then we'll go back to those problems and see if we can answer them a little bit better. I was kidding earlier that I sent you off to see what you could do because I kind of wanted to get a feel for how well the book explains things to you. You guys able to just go off and do those joins without even a second thought, or is a second thought needed? And I would expect a second thought to be needed, and it looks that way, so that's all right. But I wanted you to explore what's out there and see what we have. So where we got last time, I am so excited. I'm super thrilled. It's hard to believe that in one session last time, we were able to access the Cengage activities without any problem. Oh my God, we actually got one to work. I'm pretty excited. I didn't know what was going to happen there. I don't know about you guys, but I've heard a lot of negativity talk about some of the Cengage modules from some other classes, so I was pretty worried. And then we got our SQL Management Studio all working, and everybody was able to connect to the database, our server on Amazon Web Server. And so that's a really big deal. There was a lot of setup. It's very frustrating because as a teacher, you only do that stuff like once a year, and then you're trying to find your notes. You know how that is. Did I leave notes? Did I make notes? I got it all. We got it all. Everything's working. And so I think we're in really, really good shape to move forward. So as we practice the SQL statements that they have for us in the text, we'll add some more too. And you guys can add some more if you like. I'm going to open SQL Management Studio here real quick. And of course, it wants to open on my non-shared screen, and then it won't let me drag it over until oh, yay, there it is. Now, when you've already logged on once, the drop-down list for your server name should already be populated, and you shouldn't need to worry about setting that anymore. But do remember that it's in Canvas for us if you need it anywhere. And I just want to log on real quick. And those of you that are at home, if you haven't got this all installed and set up, right now at this point, that's okay, because I just want to show everybody some of the other databases that are set up. If you look at the databases that we have, besides the student databases, there are two others. There's the AP database and the My Guitar Shop database. And you should have access to look at those. So you should be able to click that plus sign by them, and you should be able to see what kind of tables are in those databases. So each of those give us some information, and each of the databases are basically product sales type databases, kind of like this little My Company database that we're working with. So with a lot of the same type of entities, we see those entities in a lot of test databases because that's really common for any business that we're working with. So we'll see invoices and customers and orders and those kinds of things. The reason I wanted to show you those databases is because in the videos, there are some instructor videos. So like for lesson 8, there's a video using the select statement. So if you want some additional practice, you can look at those videos, and those videos are using those other databases. So if there's ever a time where you just want to do some more practice, you're not quite understanding, you can look at those videos, and that'll be a lot more practice with the individual statements and the individual parameters that we have on them. If you look at the video, that channel, there should be some different playlists on that channel for different semesters and different online class instances, so you can look through videos if you want and find something. If there's an area that you're confused, you've looked at the Cengage video. So that's what those are. Now, if I go back to the modules, you can find the guitar shop ER diagram, and it's a PDF document that's been placed on Canvas for you. And so this shows pieces of that AP database and pieces of the guitar shop. This diagram really has all of the tables from both of those databases kind of combined into one. So you can see it's got customers and orders and items on the orders and products that tell us about those items. So all of the same, like I said, kind of entities. So any extra practice that you want, those are out there. So let's look at our book and our practice. We can practice these queries that they give us using Access. They gave us the Access databases, remember, in our student data files. We can practice these queries using SQL Server with SQL Management Studio, or we could practice them in their code thing. We don't actually have a MySQL instance running for us to use as practice, but we should see that the SQL statements are pretty much exactly the same, no matter which database management system we use. So that's why in those student data files, they give you all those different options, because you could choose whichever one you wanted. So here's our little database. I'm going to click on I think I'm going to use like the snipping tool to grab a picture of this or something so I can get back to it easier. For the one that we're working with. There we go. So we saw last time that our basic select queries start out with the keyword select, and then we supply a list of columns that we want to select. What is the result set that we want? I want this column and this column and this column. And you can find these columns from these specific tables. So I could list all of that too. So here they have an example where they've selected everything from our product table. Let's try it in Access. Can you find that Chapter 7 data files folder that we downloaded last time? Let's see if I can find mine. So we had this Chapter 7 Intro to SQL, and we decided that this one was the SailCo. So I'm going to double click on the Access database, Chapter 7 _ SailCo.mdb, and that should open that file in Microsoft Access. Now, when I do that in Microsoft Access, I need to enable content. And then Access is opened up with all of these Access objects over here on the side. So if you notice, they even have like all of the queries and stuff from the textbook example saved. But I want to look at the tables. So in order for me to actually get a visual of what this database looks like, I'm going to click on Database Tools. And I want to look at relationships, because that's going to show me like that little Access ER diagram. Now, when I'm looking at this relationships view, I can resize these entities so that I can see what all the data elements are better.
I think it would do that automatically.
What do I have to do?
I don't know, but you think it would.
You would think it would, wouldn't you? You would be so silly to think that. In the SQL Server in the Management Studio, you can go in and tell it to create a database diagram like this, and they're actually taking that capability away. So they don't like the pictures. Now I just kind of spread everything out a little bit so I could tell what's going on a little bit more. And I can see that customers can have invoices, and invoices can have line items, and each line item is associated with a given product that we sell. And each product that we sell, we get it from some vendor where we buy it. So we have all this information here in Access. That should look just the same as our database model here. So take a look and notice a little bit different in the layout, but we're seeing the same information,
You
right?
can't see it until you let go of the window.
It's not letting you see it? Sorry.
Okay, now.
Thank you for telling me. So we should be able to see we've got the same information. And I showed you last time how to do that SQL statement where we selected everything when we were using Management Studio. Well, let's do that same SQL statement in Access. I'm going to, in Access, close out of this relationship view. It'll ask me if I want to save my changes because I rearranged everything. Sure. Now, I want to create a query. So when I look at Access, I can click on the Create ribbon. There's lots of ways to do it. And I can say that I want to create a query. I'm not going to use the wizard, so I'm going to just click Query Design. And then I'm going to click Close. I'm not going to show you how to use all these fancy tools because we want to just use the SQL view. So now that we're here in this query design, do you see over here where we can change our view to SQL view? It's kind of a pain to get here, but I wanted to show you that you can basically do these same select statements using Microsoft Access. Now, if you can tell, I can't zoom in. Let's see, Shift scroll, Control scroll. So it is pretty tiny. So I'm going to instead select star from, what did they select from? Product. Let me make sure from product. Now to run this, I'm going to click this Run button. And there's my output. Did you get output from Access? Has everybody got it?
Yes.
Now, how can I switch back to that SQL to change it? I could go up to my view and go back to the SQL view. Access is going to be the hardest thing for you guys to use to practice doing SQL. You can tell Access wants to make it really draggy and droppy for you. It wants you to be able to click and it will automatically generate this SQL. But you can use Access if you're in a terrible situation and you don't have any other alternative, okay? The other thing to know from us looking at this is no matter what kind of system you create or develop, you could potentially install it on Access for a user or two if you were in that situation and that's what you wanted to do and they already had access to Access. Okay, so we have to go to the SQL view of the query tool in Microsoft Access to actually be able to enter our queries and our SQL code.
I hate this.
Huh?
I hate this already, Microsoft Access.
Do you? It actually is pretty handy and it works really well. And if we look at the queries that they have saved for us, let's see, when I double click on it, notice it runs it. If you change your view to the SQL view, you'll see the actual SQL code. And you could actually copy it from here and paste it into the SQL Server Management Studio if you wanted to. So get familiar with all of them. The more you're familiar with all of them, the better off you're going to be. But Access is kind of the one where, you know, yeah, a lot of people don't care for it. It's great. It does all sorts of wonderful things if you use it for what it's designed to do, but if you try to make it do too much, it'll bite you. Okay, so let's close out of Access. We wanted to be sure that we know we can do those same things there. And now I'm at SQL Management Studio, and that's where I want to be. Were you guys all able to access the AP database? Does it show you the tables and stuff? Because security could always be an issue. Okay. Now, I want to go to my database. I kind of, as a rule, usually when I open a tool like this, I'll kind of expand my database. And that's like typing in that use statement. I basically told SQL Management Studio, when I type any SQL code, I want you to use this database that I have open. I'm still going to put in that use statement though, just to be sure. And with our security, we shouldn't be able to do anything destructive to anybody else's tables or anything, but we always want to make sure that we're on the right database. So let's try that syntax again on our SQL Server Management Studio. Select star from product. Last time we used a different table. Now I'm sitting here at SQL Server Management Studio. I'd like to type in this query, so I'm going to use the new query button. And I'm going to do select star from product. Oops, and semicolon. And then I'm going to execute it. Again, it's mad at me. I didn't do that use statement that I said I was going to. And yours might have behaved different.
No, I didn't yell at me.
Now I've got my output again, the same output. So I've got all of my products from my product table. Now let's restrict that list a little bit. Instead of getting all of our products, let's just look at our product code, product description, product price, and product quantity on hand. So I'm going to change the star or the asterisk to be the list of columns that I want. I'm going to try caps lock since we have so much capitalization. Now with SQL Server Management Studio, the IntelliSense will try to help you type in your code. So right now mine is recognizing that this is a field name or coming up with a drop down of all of the relevant things that might be data elements for me. And I'm looking for P_code, and that's the one it's on. So I can drop that into my code several different ways. I can, whoops, do it properly. I can press tab and then continue on. There's lots of ways I like pressing tab. Then my next field is going to be P_descript. Now, since I down arrowed, I could press enter or tab, either one. And I want P_price. And P_QOH for quantity on hand. Now, if the dropdown doesn't work, it just means that the SQL Management Studio doesn't have the resources available to create those lists or isn't aware of some sort of update change that you've made to the database. It can be kind of persnickety. I'm going to go ahead and execute that. And we should see the same exact list, only our fields that we asked for.
So will it always display them in the order in which you requested them?
Yes, good question. So that's the order that it decides to put your output. So if we wanted our code to be the last thing, we could move that and put it at the end of our query, and then it would show up in that order. And when we're doing SQL, there's a lot of things like that that are just like logical, so they don't even say it out loud in a book or anybody talking about it. And if you don't notice it, you won't realize that's what's going on. So good observation, because it's just kind of one of those things, like if you're trying to teach someone how to use a mouse, you sort of forget about. Yeah, you do have to keep it on the table. You can't float it in the air. Okay, beautiful. So now we have just certain columns, and we see that we can put those in the order we want our output to be. And what if we don't like these names down here? Our columns in our output display, if we were going to give this report information to users, we might not like this key underscore column name. So we can actually give our columns aliases for the output. So let's say for our description, we would like it to have a different name. Let's say we're going to call this as DESC. And then we can put some others as if we want. Now, the reason it's mad at me, it's taking me a minute to look at it, but it's because I put this alias as DESC, and that's a reserved word because it's short for descending. And so you can see how SQL Server Management Studio is getting confused and it's throwing errors. And it's like, this is invalid syntax, it's incorrect. Well, I'm looking at the text and it's correct, but it's because it's a keyword that it's getting mad. Okay. So we have to be careful about some of those keywords. If I'd have put as ASC for ascending, that would have been a problem too. Now we can just override or give an alias to that one field, but we can give the alias to other fields too. I'm trying to reformat our SQL here. Let me get it lined up to show you. A lot of people like to format their column list in a top-down manner. This is a really nice way to do things. When we're doing things in class, I might not format things this way just because it makes it take up so much more space that it makes it harder for you guys to see the entire query on the screen. But in the real world, we like our queries formatted this way, because that way if we need to add anything like this alias after our column, we can do it really easily without messing up our column list. You can imagine in production, in our actual applications, we can have column lists in these select statements that can be very, very, very long. So they can get kind of unmanageable. So if we put each column on its own line, we can handle that a little bit better. For our price, they'd like to give it an alias. And for it, they want to show us how we can include some spaces. So if I use double quotes, unit price, I can include a space in that alias. If I didn't include the double quotes, again, the processor would not be able to understand, the parser would not be able to understand that syntax. So I'll put my double quotes around it. Now, another type of syntax I could use for something like that is square brackets. So we can see quotes around things that have spaces or invalid characters in them. We can also see square brackets. Either one works fine. Now let's run that, and we should see that our column names, our headings, use that alias now instead of that default column name. So here's our description alias and our unit price alias. So we can get them to be exactly what's required. And again, if I were running this for management at my company, I'm probably going to have some sort of standard alias that we always use, for customer number or customer name or different things like that. So we'll know what that alias should be, or someone will tell us right away. Now, when we're looking at this, let's notice some things. We can put some comments right here on this query. Let me rearrange it. I'm going to search for it. How could I do comments? SQL comments. I don't remember them showing us at all. So I'm like, well, you know, I'm teaching a lot of languages here. Single line comments start with dash dash. So I could do dash dash, select all. Multi-line comments,
Oh, that's straightforward.
yeah, are standard /star. So let's put some comments. Whoops, I've got caps lock on making me. I'm gonna have to turn it off. Can't possibly do it. So we can put some information. This query uses alias names for the description and price columns. Now we could do a lot with this query. If you have your OneNote notes open, you could copy and paste the whole query into your OneNote notes. I like doing it. I like doing that because then you can paste it into kind of a text box so you would be able to grab it back again. We could also, in SQL Server Management Studio, we could say file, save, and we could save this SQL file. So we could create a folder if we wanted to and create files for our different examples that we use in class. Now, in order to keep this one, I'm going to click on the new query button so that I keep this tab, but I'll go ahead and create a new tab. I'll save this file and that'll name my tab better too. So I'll save this as something in my CIS250 folder. So I'll call this select with alias. And just like you guys do with programming code, when you save these examples, you want to name them something that's going to be meaningful to you when you're looking for an example. Because so saving it as a select with alias hopefully would be helpful if you see an assignment that says using an alias for a column name, maybe you can find it that way. Because it always just is kind of up in the air for us as to what the best way to save it is. All right, so I want a new query. What do they want us to do next? So some things about aliases. Not all columns must use one, just like in our example. Some of the columns have aliases, some don't. The keyword as is optional, but it's recommended. It could be really confusing if we didn't have it. And aliases that contain a space must be inside a delimiter. So we're seeing that a delimiter in SQL can be either double quotes or it could be the square brackets. They have some other notes there too for us. Okay, so here we want to do a SQL statement, but we want to calculate a column. We want to kind of create a new column by using a calculation. So whenever we do a calculation in our SQL statement, we're really creating a brand new column. So I'm going to put my use statement in. And then I'll put a comment. This select statement will calculate a value. So this time we're going to select our P underscore description. Now, if you notice, my IntelliSense is not being nearly as helpful. There's something that I can kind of do that's a little bit questionable, I guess, to help it. I could come down and type my from clause so that SQL Server Management Studio knows what tables I'm looking at. And then my IntelliSense is actually much more helpful, because SQL is just a little bit backwards, right? Because if we could specify that table first, then our IntelliSense would always be helpful. But once I put my from clause in, then it starts being able to find those column names for me. I want my quantity on hand then. And my price. And the last thing I'm going to do is calculate a column. So I'm going to use the quantity on hand, and I'm going to multiply it by the price. Oops. And that's going to give me my new column. So let's run this. We should see our product description for each of our products that we have in our database. We have some cool tools. Huh?
Should we set an alias for the multiplication?
We should, don't you think? Because we're ending up with no column name, aren't we? So if we don't give it an alias, it doesn't really know what it is. And in their example, instead of saying no column name, it says EXPR1 for expression 1, and that's the way that MySQL would handle it. But yeah, the best thing for us to do would be to give that an alias. So let's see, I guess that would be our total value. They're calling it tote value. Let's run that again, and it should look better. And you can see how this happens all the time. I mean, if a manager came in and said, I need to know the total value of all the inventory we have on hand, this is the query that we could run to give them that information. Now, they'd probably want some other things too. It's, you know, life is never this simple, but it is a really good query because we're saying, okay, here's the total value of all of the things that we have in the store. So good job. Let's save that. I want to save that query as select with compute. How's our people at home doing? You guys okay? You got Management Studio working? Are you being able to follow along? Good, good, good. Thank you. Okay, so now we've saved our query, and we could use it again if we needed to. Great. So let's create another new one. Whenever we're doing math with SQL with our select statements, it follows the standard operator rules of precedence. So we're going to do the PEMDAS thing, parentheses, exponentiation, power operations. I looked at that and it took me a long time. What are they talking about? Like power tools? No, that means like power of, exponentiation, multiplications and divisions, and then addition and subtraction. So the same rules of operator precedence that we use for math problems, that's what we'll use when we're doing math using SQL. Now, this is a really cool feature that we can do a lot of math with our date fields. We talked last time about how we might end up needing a lot of dates in our database to keep track of, you know, when things happen and when things changed. So let's try a few where we're doing some date type manipulation. In this example, we have a manager that wants a list of all of the products and the date that we received them. So this is going to be the products that are in inventory, and then the warranty expiration date. So that's going to be 90 days from getting the product in. So they've got an example query for us here. Let's try it. first of all, I'm going to put my use statement. Then a comment, this query will perform date, not data, calculations, determine warranty expiration date as 90 days from receipt. So we're looking again at our product table, and we're going to select the product code. Looks like we should do a from clause, huh? Like that, it just violates all of my OCD-ness to go down and do that first, and you have to. Okay, so I'm going to do my P code. And then I want P in date. So that would be the date we received the product. Then we're going to do a calculation on our P in date. We're going to add 90 days to it and call that our EXP date for expiration date. They have a really good write-up in your textbook about doing date math calculations. I'm going to execute this.
How does it know the date?
Good question. So whenever we're looking at our database management system, if we do calculations when we're working with a date, this would give us the impression that it's going to default to days. So we would probably have to put like some sort of parameter to say months, to add months or years to our date. Let's look at the other examples they give us, and then we'll go do some research because there's a lot of capabilities with dates. And that's really cool because if you think about, like, I know you guys have all heard stories about Y2K, and the deal was that disk space used to be really, really expensive. And so developers, if they were going to carry 5 million rows in a table, and they had 7 dates on that table, you know, the date that this table was created, the date it was last updated, the employee's, their birthday, you know, all these different dates. They were like, dang, we carry that century and all of those dates. That's going to take like 2 gig of disk space, which is going to be like $40,000, which is how much it was. And so stuff was super expensive. And so they said, we'll just assume the century is 19 because that's how it's going to be forever, right? We'll never get to the 21st century. That's craziness. You know, like the who said, we'll all die before we get old. But anyways, we made it and we got to the 21st century. And now all of a sudden, all these programs were crashing. So think the big one that they always talked about was a nuclear reactor. So think about a nuclear reactor. And you wrote the code in this monitoring system for this nuclear reactor. And part of your code says, is this second greater than the last second? Because if it's not, I have somehow been attacked and I better shut down the nuclear reactor, right? Because the time is wrong. So some sort of sabotage has occurred. So when we went from 99 to 00, all of a sudden the time was not going to be greater for that second. It was going to be less than. And so any sort of activity like that, that was very involved and had a lot of security built in, was risking a shutdown event because the second would not be greater. So all of that really brought out a lot of need for the ability to do date calculations easily and to have the date properties, all that code hidden in our database management system makes it to where we don't have to go out and update 500 different programs to make this work because there's a change happening, right, in the way it was structured originally. So if we can keep things like that in our database management system, we can keep it out of our program code and insulate them. So you guys know there's another one coming, right? What's the next one that's coming? The Linux date thing, 2045.
I haven't heard of that.
Huh?
I haven't heard of that.
You haven't heard of it? I'll let you look. I don't know if it's still an issue. Linux originally was based on Unix, and the Unix operating system they actually like hard coded a date table in kind of the operating system, and it goes up to 2045. And then it stops. And so I've heard in some cases that some Linuxes have taken care of that problem, but we can look. Because it'll be a great opportunity for you guys. Oh, 2038, I said 2045. And now they say Linux is ready for the end of time. So it looks like an opportunity for some consulting. Just saying, consultants made a whole bunch of money for the Y2K problem, going out and fixing all that code that shouldn't have been made that way in the first place. And it probably will happen again. But because this is all dependent on a specific operating system, or really one that they're all based on, it shouldn't be that big of a deal. So they have some workarounds and different things like that. I'll let you guys look into it. It's really interesting. But so dates are a really big deal. We have all these problems with dates, and developers from the very beginning try to figure out how to handle them. So all of the things that we can do automatically are a really big deal. So we've got this one saved. Let's copy it. I'm going to copy this whole query and create a new one. You guys will just be like, the Unix date problem, not an issue. We survived 2020. So let's subtract it instead. Can we do it that easy?
Yeah.
Yeah, you can. Let's run it. And now we should see our expiration date is beforehand, and it handles year ends properly. Because we're using built-in functions, it handles leap years properly. We don't have to worry about coming up with all of that logic on our own. That's very nice. And they always say, why do programmers keep reinventing the wheel? Well, in this case, we can kind of get away from that a little bit. Great, so we see that we can do a lot of different queries, and we can control what data we're getting. We can do calculations to create new columns in our output. So we really have control of everything. The next thing they want to show us is how to list unique values. So if I look at our product codes here, they should all be unique. I'm going to go back to one of our earlier queries, where we listed all of our descriptions and all of that kind of stuff. And I want to see, most of our products seem to have pretty unique data. So what they're going to have us take a look at is our vendor code. Let's look at all of the data in our product table again. I've got to create a new query because I have gotten rid of that query that selected everything. And I'm just going to select star from product. So in our database, we've noticed that we can have a vendor code appear in more than one product row. And that makes sense, right? Because if we buy, I don't know what our vendors are, but if we buy this saw blade from, O. Henry's, then we probably buy this other saw blade from O. Henry's too. So this V code is a foreign key, that points into our vendor table, and it tells us who we bought this product from. So we might have bought some, from Lowe's, whatever. We've got all our different vendors. Well, we can actually use our product table to list each of these vendors. Let's do that. Let's select just our V_code. If I do that, my management might say, I need a list of all of the companies we buy things from. Well, this would be our vendor code list. So here's our list, but we have all these duplicates in it. And they're going to look at that and be like, well, could I just have them once, please? Because I don't need to see them on the list more than once. So we can use the distinct keyword. So I'm going to press enter here to move my from clause down to its own line like it should be. The distinct keyword is a keyword that impacts the select statement. So it goes in the select column list. Now, if I run this way with that distinct keyword, I should see that I've limited my list to just those distinct values.
Get only unique values.
Only unique values, right? Now, in this case, notice how our null values are shown. If shown is a null value. So we could have, some differences in how that's handled with our different database management systems. So just be aware of that. Now, whenever we're working with our query, we, in this case, have only been looking at one table. And you guys know that we often have to join or look at data from more than one table to really have meaningful information for us. So they call that a join, where we need to look at things in more than one table. When we look at this V code, we said this is a foreign key that tells us which vendor we buy this product from. So I could use that foreign key to go find that actual vendor's information. So more than just this vendor list, maybe I need to list some other things about the vendor. So let's see what we could do here. Here's an example. In these results, we have some stuff from our product table, the description and the price, but then we also have some information from our vendor table. So for each product, we're seeing the name of the vendor, their contact information, phone number, stuff like that. So in order for us to get information from two different tables, we have to use a join. Last time I just brought up those notes and let you copy them, and there wasn't a lot of context to go off of. So now we can finally start looking at some join syntax and see what they're talking about. So let's start with this first one. I'm going to open a new query window, and I'm going to use my database. And for our first query, this is going to use a natural join. So a natural join returns all rows with matching values in the blah, blah join column and eliminates duplicate columns. So duplicate values. Now, whenever we're using a natural join, the tables have to have the same column names. So the database management system can tell, oh yeah, these must be the same thing because they're the same names, right? So it's not going to be super smart. It's got to know. So let's try one. Select. And for this select statement, we're going to get some information from our customer table, and we're going to add some information for the invoices that we have generated for that customer. Here's our picture. We have our customer over here in our database. We have customer code, some name information, and what their balance is. And every time a customer buys something from us, we generate an invoice. That invoice has a unique number, and it has a foreign key to tell us what customer this invoice is for, and it has a date. Now, for every item they buy on that invoice, we have a line item. Our line item table has foreign keys of the invoice number and the line item number. Those are a combination key to make that primary key unique. The invoice number is the foreign key that points back to the invoice. So we're going to query our customers and see what all customers have bought things from us. So we want to select our customer code. Oh, we should do our from clause, huh? From customer. Now our from clause is what's going to be updated for our join information. We saw in that last query that the syntax that we were adding went into our select statement. But whenever we're doing a join statement, the syntax is going to go into our from clause. Okay, so now I should be able to select my column list without having to type everything because I've got my from clause in. So I'm going to select my customer code, my customer last name, my customer, oops, no more customer stuff, my invoice number, and my invoice date. Now in our SQL Server implementation, SQL Server is saying, I don't know what you want here because I don't know what you're talking about. It says that customer code is ambiguous. Do you want the customer code that is on the customer table, or do you want the customer code that is on the invoice table? Well, we would like them to match. So we'll say we would like to use the customer code. Still mad at me. See what I'm doing wrong here. I think I'm doing anything wrong. Natural join invoice. So let's go look. We might be seeing some differences in our different database management systems. So I'm going to search SQL Server natural join. No, no, do you see it? No, you can't do that. It says no, and thank the lucky stars. So we do have a little bit of syntax difference. So in our textbook, they show you how to do that natural join, and it's something that you can do in MySQL, the database management system that they're using, but it's a little bit of a difference for us. So let's look at why. So this isn't going to be a confusing thing, don't worry. It's going to make sense when we look at why and what's going on. When we're talking about a natural join or letting the database management system figure it out on its own, we're saying that when the database management system looks at our whole schema and decides how to handle our query, you know, there's some thinking that has to go on there, almost some artificial intelligence, not exactly, but sort of, where our database management system looks at our schema and decides how it's going to approach this data. Right now, we are saying in our from clause, from customer. So the database management system says, oh, I think I will start with this entity then. And every time I look at a customer, I'll know that I have customer information. And then after I get all the customers, maybe I'll go look at all the invoices. And every time I get an invoice, I'll already have the customer information for that. Or maybe the database management system decides to handle it a different way. And it says, oh, for every customer I encounter, I'm going to go look at all the invoices and see if I see any invoices for that customer. And then once I gather those, I'll go back and look at the next customer. That query plan is being developed by the database management system based on the information that we supply in our select statement. So it's going to use the defined database in our select statement to decide how it's going to run this query. When we say natural join, we're saying find a key field that is the same on these two tables and use it to join the data. We're putting an awfully lot on the database management system. We're not saying do the left join or the right join or any of those other joins we saw last time. We're saying you just kind of figure it out, do it a natural join, so it's discouraged. So I'm going to put that on here. Discouraged. Now to comment that out, I'm going to do a plus or a star slash and a star slash. And I'm going to copy it. And I'm going to show you how we can do this with our SQL Server Management Studio. So SQL Server Management Studio, the SQL server that we're using, has its own syntax for doing this natural join. Now, you can see where we're going to run into some problems here with using all these different database management systems, but in the end, it's going to make you so much more powerful because you know how to use them all. For SQL Server, they were like, what in the world's a natural join? You just made that crap up. We're just going to put a comma here and have it be called an implicit join. So you, database management system, you go out there and figure out what to do. Also, discouraged. Why am I showing you these? It's frustrating, it's confusing. I'm showing you natural joins and then saying this doesn't work. And I'm showing you this other, and saying this doesn't work, don't do this. Why I'm showing you this is you're going to see samples of this type of code everywhere you look. So if you go out and you're Google searching how to do things, you be very aware that these implicit joins, natural joins, are not okay. So whenever we do joins, we're going to actually say left join, right join, or whatever kind of join we're doing. We're not going to do these lazy joins. And why you're going to find them everywhere, that's how they did SQL for a long, long time. So for a long time, we would just write our SQL code and we would let the database management system go thrash out there and figure out how to satisfy our query. And then they realized, you know, if we actually said, hey, database management system, look at the customer first, doing a left join, then we can control how it accesses the database a little bit more, and we can make sure our queries run in a good way. So let's do this as a left join. I still have this thing copied, so I'm going to open a new query and do my use. So I go through all that frustration to tell you guys, don't do it that way. And you're going to see it that way all over the place. Because it was just a widely accepted way of doing things for a really long time. I always love it when students turn things in like that. And they are kind of trying to explain it to me like I just don't understand. Okay, here's how we're going to do it. Instead, we have our customer and we're just going to say, I want to get that data from my customer and I want you to join the invoice table to my customer using that customer code. Sorry,
Live debugging.
I've got it on the wrong thing. Join invoice. No, it's customer code. Sorry, I'm looking at the wrong query. Is it working for you?
No.
Is it mad? I think we've got some other syntax differences. So let's go to our MindTap stuff and we'll use the syntax they like and get some joins done. So before we worry too much about the specific from clause in our syntax, let's look at our different types of joins because I showed you some pictures but didn't really give you much information there. If I have a database like this one and I want to list all of the customers, and if the customer has an invoice, I want to list that invoice also. Then my syntax would say from customer join invoice, and I would join on that customer code because that's my key field that's common between the two tables, right? So that would be my left join. Now, if I want a list of all of the products that we buy or sell, I could look at all of my entities in my product table. But if I want to look at every time a product has been sold, then I would need to join the product to line items, and I would need to join line items to invoices. And when I make all those connections, I would be able to see all of the invoices that we had for a given product. So the type of join that I use is going to determine how I go about that. If I want to see all of the products, then my product table would be the primary table in my using clause. Then I would see products, whether they had any invoices or not, in a left join. Now, if I change that and I said, no, I want a right join, then I would only see products that had an invoice. The table on the right, the table that I was joining to, would be the one that was controlling my output. So the differences we're seeing in our syntax are having to do with how we specify how to create that join.
Figured it out.
Figured it out. What'd you get? Show us.
Here.
Do you want me to share it?
I don't have.
Don't have it open? Well, just tell me what to do then.
So instead of trying to put it inside of the from statement, you make a new, I guess you could put it in the from statement, it doesn't really matter, but you make a left join statement, invoice on code equals invoice.passcode. Try the left join instead of just join. There you go.
Now let's see what that gives us. Yay! Run it. So for our left join, this is perfect. Because we're saying we're doing a left join, our customer is controlling it. We're seeing output for every customer because the customer is the left, right? So even if they don't have any invoices, we're just seeing null data for their invoices. So look at your output here because that's what's important for our left join. Now let's change it to a right join. And run it. Now, because we want our table on the right, our invoice table to control this query, we're only seeing output when we have an invoice. So our database management system used the invoice table to control this query. For every invoice, it said, oh, I'll go get the customer information. Another invoice, oh, I'll go get the customer information. Where when we did a left join, we started at the customer and the database management system said, oh, I'll go get invoices. Another customer, I'll go get invoices. So we're seeing completely different information because of our selection. So no matter what, we have 1001 through 1008 invoices. And if we do a right join, the invoices all show up and we only see customers that have invoices. If we switch it back to left, then we see all our customers, even if they don't have invoices.
Brady's isn't working for no apparent reason.
Huh?
Brady's code is exactly the same as mine, and it doesn't work.
Saying invalid column.
Invoice, put the word invoice after on. After.
Oh, I can see that. There you go. No, it's before.
Is it before?
It's before.
It's before. Don't ask me now.
At least you caught it. I couldn't see it.
Yay. Okay, so how can we make that syntax easier to read? Lots of different ways that people like. Some people like to press enter and indent so that their join statement is on its own line. Some people like to press enter and indent even the on clause, so you can do it however you like.
So I found the answer to this on W3 Tools.
Did you find it?
Yeah, schools, W3 schools.
What should I look for?
Just left join, SQL left join. It's on the left side right there.
I see it. So our problem is that we're looking at some different syntax, aren't we?
Why is that one?
So we're using SQL Server syntax, which is what W3 Schools is using, so we're matching up good, but it's not what Cengage is using. So let's see how we would have to do that for our Cengage stuff. For Cengage, it's this on part that's different, isn't it? Let me bring it up and make sure. They say using the foreign key. So let me put a new line under here. Using passcode that would be the MySQL syntax. So everything else should be exactly the same. Now this is a hard one because we've got all this Cengage content. And I think that we're better off to stick with our Cengage stuff and follow along with their samples, even though the syntax is going to be a little bit different than SQL Server.
It's just like trying to learn 3 programming
It
languages
is,
at
it's
the same time.
really hard, and so I'm not sure what the right thing for us to do is. So I'd like to have I need like an inspiration here. I'm like, please give me an idea. What would be the best thing for us to do? Because I think we should use our Cengage stuff, because I think you guys are going to get that immediate feedback from it. You're going to know if you're doing it right. It's going to match your book with all of your examples, but it's not going to match W3 schools.
Does Cengage have a practice environment?
That's what I'm not seeing, because all I'm seeing is that we have the code. Now, we can create, I think I can create an AWS server with a MySQL syntax so that we would have a practice environment. So I'm just trying to decide what the best thing for us to do is. The biggest issue is this syntax, the SQL Server syntax, is what we're going to be seeing on your certification exam. But understanding the concept of the right joins and the left joins is more important than the actual syntax. So it's a really hard one. So I think we're going to stick with the MySQL syntax, and I'll look at creating a MySQL server so that we have our practice environment in the same way. But we definitely do have this issue, and it is going to affect all of you guys. So any sort of opinion you have, let me know. My thinking is that we're better off to use the Cengage content because you've got all of those practice problems, and because that's what your textbook is showing you the right syntax is to use. So I hate to switch off to something else, but we have them both. So, if you come up with any sort of inspirational thoughts, let me know.
I mean, personally, I prefer SQL, the SQL Server, because like it's very explicit, like left join, and you're talking about the left customer code in which you just wrote.
Right. Now, so the thing is though, whenever you're looking at your left join, they're talking about the from clause.
Whatever.
Left, right.
Or at least you know what codes you're
I
talking
like
about.
it better too,
Yeah.
I really do. But in this syntax, it's kind of like, more like what you use in create table. So they have their different varieties of things. So we'll do a little more research, meaning I'll do a little research, see what we can find out, and we'll kind of go from there. So let's do a few of these first problems. Make sure your grade is supported. That's what I'm worried about. I don't want you guys stressing about that, because that's not going to be a problem.
Session has expired. Get out.
Okay, so we had the first one done. We did our awesome like syntax. Credit. Problem 2. We have the employee job and project tables that are from the construction code database. And that database, they showed us up here, didn't they? Where have I got that?
That's why I was having problems with this. I was using W3 schools.
Yeah, I was messing with you guys for sure. Where is the picture? Why can't I find it?
It's like the book thing.
The book thing?
And then go to the previous page.
Thank you. Okay, I'm going to snip this again. And I want problem 2. So looking at our database, we have just 4 entities: our job, our employee, our assignment, and our project. Because we could have many employees working on many projects, our assignment table acts as a link table between the project and the employee. So we could use it to join those pieces of information. So problem 2, we've got employee, job, and project tables. Write the SQL code that will join the job, employee, and project tables using common attributes. So I guess I need to get rid of this.
I just selected it and then control question mark that commented it out.
Oh, that's nice.
Okay. Thank you. Very nice. All right, so we want to do our select statement, and we want those specific columns, and we can see them down there. So let's just go ahead and list them. We want proj underscore name, proj underscore value, proj underscore balance, proj underscore val name. Then some things from our employee table. Oops, that should have been emp last name, not proj. So after project balance, we want to go to our employee table, emp last name, and emp first name, emp initial. And now we're going to be looking at our job table. So we want job code, job description, and job charge per hour. So to me, looking at the output that were requested, they really want the job to be the kind of controlling table. So I'm going to put job first in our from clause, from job. And then they want us to do a natural join with the assignment. And our on clause there
Or is it using?
using,
Is it? That's a question.
I'm going to have to bring up that syntax. My SQL natural join syntax. So what's w3resource.com? It looks like we might be able to use the on, but I don't think they'll let us. Okay, so using column list. So our column list would be or. For our job, what are we wanting to join the assignment on? Job number, job code, it looks like. Can we run that? We don't have everything yet. Does it complain at us too much?
hate this.
So we've got our job and assignment. So I'm going to change this to be from project, natural join assignment using project num. So we're saying start at the project and go find the assignment based on that project number key. Then from the assignment, go find the employee using the employee num, emp num. So like that.
Here it said there is no project number.
It's project code. What is it, project code? No, what?
So project code.
Project. I don't even know.
I see proj num. Proj underscore num.
Val.
Why is it?
I guess I
You have an error using.
Proj value.
What does it want?
Proj value.
Proj value instead of proj num.
Oh, there is a proj num. Never mind.
Yeah, but we don't have it in our select, so it won't see it.
We shouldn't have to have it in our select to do a join, but it's looking like we do.
But then it'll show up in our table. Oh my god,
Yeah.
this is terrible.
Oh no! What's gonna happen? We can add, let's add it and see if that makes it happy. Okay, hang on. I go find the answers. No fun. See if they give them to us.
You're not going to share all the answers on the screen?
Well, it's not really the ones you want, don't worry. They say I should have them. Let's see. This says it's MySQL, and it's showing us using the on clauses. Let me copy this over. Proj name, proj value, proj values. We have everything right. I'm gonna fix it. From project join. They say we want to join the job instead of the assignment. So let's try that. So let's join job. And that would be our job code instead of project num. Where's our picture here?
There is no assignment on problem 2 at all.
So it's project, job, employee that we need. Project, job, employee. Is that better? Not much. Using job code. So here's what they give us as the answer. They say we don't have to use all the syntax that the textbook was giving us, that we can say join job on. Let me rearrange them. I'm going to put from project. They want us to say from project join employee. And they want us to say on project dot emp num, this looks good, equals employee dot emp num. And then join, join job. On employee dot job code equal job dot job code. Well, that was fun. My blindness caused us trouble. So I thought that they wanted us to get this assignment, and I was making us go off in the wrong path. Because what they really want is, for each project, we want to know the employees that are on it, and I guess like their job code or something. So let's see if it likes that better. Job code in field list is ambiguous. So line 6, it's saying this job code is ambiguous. Do you want the job code from your job table, or do you want the job code from your employee table? Now, when we're doing a join like this, it does matter a little bit, but basically we should be okay specifying the job code from any of our tables because we're wanting them to all match on that field. Now I'm going to run that again after specifying that job code. Whoa, painful. Does it like it?
No.
Review the results. Incomplete. So what's wrong with us here? Job charge per hour. It looks like we're like in a different order. Do what? Oh, they say they would like it sorted by project value. We can do that. So at the very end of our syntax, before our semicolon, let's add order by proj underscore value. Now that should give us, our smaller projects first. That looks closer to the right order. So I'm seeing rolling tide, that project value and the balance. That looks good. Now before we go any further, let's kind of stop and consider what we've learned. What have we learned? The book is going to show us one join syntax, but the exercises and SQL Server and everybody else is going to use this other join syntax. So I'll make us kind of a cheat sheet to compare them back and forth, and we should be able to use this common syntax no matter what. Sorry, it's been painful in observing that and figuring it out. Is yours not working? Why are you giving it the evil look? Oh, somebody's chatting too.
For me, might be, I'm equally dumb. It's fine. We're in hatred.
Is it gonna like it?
Hey,
Let's leave on that successful note.
I don't know why it doesn't.
It doesn't like yours? Here,
Like,
share
Make
with
sure you
us.
don't have an extra semicolon.
Ah!
I hate this programming language. I hate Cengage.
No, you're gonna love it all. It'll be good. Don't you worry.
yeah, like starting out the programming language, you have that point where like anticipated.
We've got this now.
It's like more ambiguous Python.
We've got it now. You're going to
Figure
beat
out,
this
like,
game.
okay,
What's wrong with it? The wrong headers were returned.
Oh, that's why.
You see why?
Yeah, I didn't realize I could drag this. I was like, this looks the same. Oh wait, I can drag this. Okay, one sec. Maybe I can figure it out. So,
BGE and initial job code, job charge hour.
oh, project. That's a very good.
Oh, you've got,
I think you're missing a column.
get rid of that project number, that last column that we added trying to resolve our issues.
Where you found
We don't need that.
Whoa.
Woohoo. Close it. I'll make us a cheat sheet. You guys can look at a couple of those problems again on your own, trying to use this other syntax. But if you want to just wait until Tuesday, we'll do the rest of them together and get this one completed and the other one that's due Tuesday. So
So do the assignments use SQL Server syntax?
it looks like we can use that syntax.
Okay,
That's good.
That's good.
good.
Chelsea, we will do the projects that are due Tuesday on Tuesday together in class.
Thank you.
So we do not worry about them. Do read through the material and start trying to sort this data in your brain.
We'll teach you the wrong information.
And then we will resort it again on Tuesday and get it all put into the right spot. Don't worry. We'll get it. We'll get it. Sorry, I just was like, oh no, MySQL's not going to take our standard syntax, but it is. So we're good. We can handle it. Good job, everybody. I'm going to end this thing and we're going to call it a day.